This presentation is entitled Object Morphing. Now, object morphing is a revolutionary new concept introduced by divine inspirations. Now, let me give you an example of what I mean by object morphing. Imagine the following scenario. You're filling out your income tax, and you have a choice of filling out either the long form or the short form. And imagine you choose to fill out the short form. And you get halfway through it, and you realize, gosh, I should be really filling out the long form. And you take a look at the long form, and half the questions are the same questions that you've just got done filling out in the short form. What you want to do there is really take a scissors and cut out your answers, the questions you already answered, and paste them onto the new form. That is an example of what is meant by object morphing.
Object morphing. There are a number of challenges today associated with information technology. In this presentation, we're going to examine two of them. Something called fragility, which is the situation where you have an enterprise system that's multi-tiered and you make changes in one of the tiers. You oftentimes get a ripple effect where you break other layers of the architecture. A second challenge is one of rigidity, the inability to easily modify data schemas on the fly. To address the challenges identified on the previous slide, we're going to look at a technology called TCSQL. In particular, we're going to look at a feature called object morphing. The object-oriented paradigm can be represented as a graph problem. So here we have a class here called class 1, which has properties A, B, and C, and a has-a relationship between the class definition and its associated properties. We also have another class here called class 1.1 with properties D and E. And we see a relationship here between these two nodes, an is-a relationship, meaning that class 1.1 is a specialization of class 1. Now let's look at a graph here. Let's look at what happens if we want to instantiate class 1.1. Let's look at the equivalent object graph. In this case, it would look like the following. Assuming we want to instantiate class 1.1 and we're going to call that object 1, what happens is the following. We first want to instantiate properties D and E, and then we want to look at this inheritance is a link here to inherit properties A, B, and C, which is what you see down here. Okay, now let's look at the relational tables needed to support this paradigm here. So we have the notion of a class table here, which represents the nodes of our class graph here. It's basically a name-value pair here, and we have a type column here, and legal type values. This represents basic class types here. We have a class connection table of parent-child nodes here and a connection type here. In this case, it's going to be either has-a or is-a. And then we have a transitive closure table representing the transitive closure of this class graph. And assume for a minute that this transitive closure table is automatically populated and managed whenever nodes or connections are added or deleted in this class graph. Let's look at the tables needed to support our object graph here. We have a table called object, which represents the nodes of our object graph here. Again, it is basically a name-value pair with a class column here representing the kind of class that we're instantiating here, including the class properties. We also have an object connection table here, which represents the connections of our object graph. So it's a parent-child pair, again with connection type. And we have a transitive closure table associated with our object graph. And assume here also that this transitive closure table is maintained automatically whenever nodes or connections are added or deleted in our object graph here. So this whole paradigm here I'm describing here with these 6 relational database tables is something known as a soft schema. With this soft scheme model, let's look at an example of instantiating a class instance here. So we have a class graph here, and all the data in this graph can be represented with 2 tables here. So we have a class table representing all of the nodes of this graph. we have a class connection table showing all of the connections here. Now I didn't bother showing all of them. I just showed a few of the rows here. Okay, now let's look at what happens when we want to instantiate this particular node here, a boy. What we're going to do is instantiate this boy. We're going to call this instantiation Andy here. And what is going to happen behind the scenes is TCSQL is going to figure out all of the particular properties that need to be inherited here, and it will populate appropriate object and object connection tables here. And these two tables will represent an object graph that looks like the following here. Notice here that I've introduced a new kind of relationship, a has-not relationship. TCSQL supports the ability to do inheritance override here. Now, if you were to implement this in an object-oriented language such as C# or Java, this is the object graph equivalent what you would get here. Now, the real power and beauty here is I did this directly in a relational database using standard SQL. Let's take a look at the TCSQL feature called object morphing. We're going to use the following example, one of filling out your income tax. When filling out your income tax, you have a choice. You can either use the short form or long form here. And we've indicated that in this Venn diagram here. So here we have our short form class and the properties of the short form class, which are really the questions you're going to ask in the short form. This red oval here represents the long form and the questions you would ask when filling out the long form. And notice there's an intersection between these two egg-shaped figures here. And so these are the questions in common. So let's assume for a second that you'd like to fill out the short form here. So in our TCSQL system here, what you would do is do an insert into our object table. We're going to call it my form, and it's of type short form here. And so you can imagine the associated properties being instantiated here. And imagine after some time you fill out some of the questions here. In other words, you're doing an update of these particular properties here. And somewhere down the line you go, gosh, I should be filling out the long form, not the short form. Well, what you really want to do here is you want to preserve the questions that are in common and the answers you have already given to some of the questions here. And so the procedure we're going to do is one of a morph operation here. And we do that by doing an update statement here. So we say update object and set class equal to long form, where my form name was called my form here. And what TCSQL does magically behind the scenes is the following. It grabs all the questions that are in common here and preserves the answer you gave on the previous property values here. It removes the questions that no longer pertain and adds the new questions here. So this is what is meant by object morphing. Let's look at a clever use of the concept of object morphing. Imagine for a second that we have a class definition as follows. We have a class 1 with properties A and B. We have another class here called class 1.1 with property C. And class 1.1 is a specialization of this more general class called class 1. Imagine we instantiate class 1.1. We create an instance called object 1 here. And we do this via executing an insert statement here. And so what we get is the following equivalent here. We get properties C instantiated and properties A and B are instantiated via inheritance here. Imagine at some point we provide values here to these properties here. And then imagine at some point down the road the following happens. We change our definition here. So class 1.1, which only had property C before, we add a property D. And the more general class called class 1, we remove property A. Notice now that our updated class definition is out of sync with the objects that we've created here. So the way to rectify the problem is we do an object morph. And so what we do is we execute an update statement. Update object set class equal to 1.1. That's what we're trying to rectify here, where name equal object 1. And so what happens behind the scenes is TCSQL will magically add property D here that we see as part of class 1.1 and will remove property A. So this is a special case of object morphing. So why is this valuable? Well, first of all, I claim it reflects reality. It's very common to define a process and later on down the road needing to make process changes. And so whenever you make process changes, what you need to do is go back and update your instantiated project data. And so what we've demonstrated here via object morphing is we've simplified that process.